For most of human history, there was one thing machines could never truly replace: the human body. Machines could lift more than us, calculate faster than us, travel farther than us, and build things with incredible precision. But they were machines. They stayed bolted to factory floors, hidden behind safety barriers, locked inside warehouses. They didn't walk through the same doors we did. They didn't climb the same stairs. They didn't reach for the same tools. And they certainly didn't look like us. But that is beginning to change. Quietly, across factories, laboratories, warehouses, and technology companies around the world, a new kind of worker is being trained. It has 2 legs, 2 arms, hands, cameras for eyes, artificial intelligence for a brain. And unlike the industrial robots that came before it, this machine is being designed to operate in a world built for humans. The humanoid robot has spent decades trapped inside science fiction. Now, it is beginning to clock in for work, and the race to build it may become one of the biggest technology competitions of our generation. In August 2026, one of the companies at the center of this race made headlines. Chinese robotics company Unitree priced its Shanghai stock market offering at a valuation of roughly $9 billion. Only a few years earlier, humanoid robots were mostly demonstrations, videos of machines walking, dancing, running, jumping, and occasionally falling over. Now, investors are placing billions of dollars behind the idea that these machines could become a real industry. And something else happened. DeepSeek, one of China's best-known artificial intelligence companies, invested roughly $20 million into Unitree as part of the offering. The reason matters. Unitree knows how to build machines that move. DeepSeek specializes in artificial intelligence. Put those 2 worlds together, and you begin to see the real ambition. The goal is no longer simply to create a robot that can walk like a human. The goal is to create a robot that can understand the world around it and decide what to do next. That difference changes everything, because walking is impressive, but walking doesn't make a worker. A useful humanoid robot has to recognize objects, understand instructions, navigate changing environments, use tools, respond when something goes wrong, remember what it learned, and perform the same job thousands of times without turning every unexpected situation into a disaster. That is much harder. Consider something as simple as picking up a box. For a person, it's almost automatic. You see the box. You estimate its size. You reach toward it. Your fingers adjust. Your muscles respond to its weight. Your balance changes before you consciously realize it. If the box starts slipping, your body reacts. All of this happens in seconds. But for a robot, every part of that action can become a separate engineering problem. Where exactly is the box? How heavy is it? Is the surface slippery? How hard should the fingers squeeze? What happens if a person suddenly walks past? What if another object is blocking the path? What if the box is different from every box the robot trained on? Humans solve these problems using a lifetime of experience. Robots need data. And that is why one of the strangest new industries in technology is emerging. Humans are teaching robots how to be human workers. A person performs a movement. The robot observes it. The machine gathers information about position, force, motion, and timing. Again, and again, and again. Thousands of examples can eventually become training material for artificial intelligence. In other words, the robot worker of the future may learn its first job by watching today's worker do it. This is sometimes called embodied intelligence. Artificial intelligence doesn't simply answer questions on a screen. It inhabits a physical machine. It sees, moves, touches, and interacts with the real world. And suddenly, the AI revolution is no longer confined to computers. It has arms and legs. This helps explain why factories have become one of the first major testing grounds. Factories are designed for humans. Doors are human-sized. Workstations are positioned for human hands. Tools are made for human fingers. Shelves are built at human height. A traditional robot often requires the environment to be redesigned around the machine. A humanoid robot offers a different promise. Instead of changing the factory for the robot, change the robot so it can use the factory that already exists. That idea is enormously attractive. A humanoid could theoretically walk into a workplace and perform tasks using much of the same infrastructure humans already use. That doesn't mean it can do everything. Not even close. But companies are beginning to test whether the idea can work. UBTech says its full-size humanoid robots are already being deployed in manufacturing, logistics, electronics, and other industrial environments. And in 2026, the company announced European logistics deployments through a partnership covering Germany, Austria, and Switzerland. This is the moment when the story begins to change, because technology usually becomes truly important when it becomes boring. The first automobile was a spectacle. Eventually, it became transportation. The first computer filled a room. Eventually, people carried computers in their pockets. The first industrial robot looked like the future. Eventually, people stopped noticing robotic arms inside factories. Humanoid robots may be approaching their own version of that transition, not from impossible to perfect, but from demonstration to deployment. And the companies building them aren't simply competing over who can make the most impressive video. They are competing over something much larger: cost, reliability, artificial intelligence, manufacturing capacity, battery life, dexterity, safety, and, perhaps most importantly, data. Because every robot operating in the physical world can potentially generate more information about how physical tasks are performed. One machine learns to sort packages, another learns to move materials, another learns to work with tools. If those experiences can improve future systems, then deploying robots can create a powerful cycle. More robots create more experience. More experience improves the AI. Better AI makes the robots more useful. More useful robots create demand for more robots. And that is when an experimental technology can suddenly become an industry. China clearly wants to be one of the leaders of that industry. Unitree has become one of the world's most recognizable robot manufacturers, while UBTech and other Chinese companies are pushing toward commercial deployments. But this is not only a Chinese race. American companies are pursuing the same future. Tesla has been developing Optimus. Boston Dynamics has continued developing Atlas. Other startups are building machines for logistics, manufacturing, and general physical work. Some developers believe humanoid robots could eventually become as important to the physical economy as computers became to office work. That is an enormous claim, and history suggests enormous claims deserve skepticism, because the robot industry has promised revolutionary machines before. For decades, people were told robots would soon be everywhere. But homes did not fill with humanoid assistants. Factories did not eliminate human labor. Robots remained extremely good at narrow, repetitive tasks, and surprisingly bad at many things humans find simple. That remains one of the biggest challenges today. A robot can perform an impressive demonstration in a controlled environment. The real world is not controlled. Something falls. A door is left partially open. A tool is in the wrong place. Lighting changes. A person interrupts. The floor is wet. A package has a strange shape. The machine doesn't know what to do. Humans improvise constantly. Robots still struggle with the unexpected. And that may be the difference between a robot that looks incredible in a video and a robot that can actually hold down a job. Reliability is everything. Imagine a human employee successfully completing a task 90% of the time. That employee would probably not remain employed for very long. Industrial machines are expected to work repeatedly, predictably, safely. A robot that performs 9 tasks perfectly and causes a problem on the 10th may not save a company money. It may create more work. That is why the humanoid revolution may move more slowly than some headlines suggest. But slow does not mean unimportant. The first robots do not have to replace every worker. They only have to become useful enough in certain jobs. Jobs where work is repetitive, where labor shortages exist, where the environment is dangerous, where tasks happen around the clock, where businesses already struggle to find enough people. That is where humanoids could gain their first foothold. And then comes the question almost everyone eventually asks. What happens to human jobs? It is tempting to imagine a simple future. Robot enters factory. Human leaves factory. But technological change rarely happens that neatly. Automation can eliminate some tasks while creating others. A company deploying humanoid robots may need technicians, maintenance workers, software specialists, supervisors, data operators, safety engineers. New jobs can emerge around the machines. At the same time, workers performing repetitive physical tasks may face real competition if robots eventually become cheaper and more reliable. Both things can be true. Technology can create opportunity while disrupting existing work. The difficult part is predicting who experiences which side. And the robot race is moving beyond factories. Companies envision machines eventually working in hospitals, warehouses, hotels, retail stores, elder care environments, and possibly homes. A robot that can carry supplies in a warehouse could eventually carry groceries in a house. A robot that can move parts inside a factory might eventually help an older person move objects around a room. A robot trained to recognize tools may someday help with basic household chores. That's the dream. A general-purpose machine, not a dishwasher, not a vacuum cleaner, not a robotic arm. One physical platform capable of learning many different jobs. If that happens, the economic implications become enormous. But the closer robots move toward everyday human environments, the more complicated the questions become. How strong should a household robot be? Who is responsible if it damages something? What information should its cameras record? Should a robot operating inside your home send data to remote servers? What happens if it is hacked? Can it recognize children, pets, visitors, emergency situations? Who gets access to the information it collects? The machine may look like a mechanical person, but behind that body could be cameras, microphones, sensors, wireless connections, and artificial intelligence, gathering enormous amounts of information about the environment around it. A helpful robot could also become one of the most powerful sensing devices ever placed inside a private home. That creates a strange trade-off. For the robot to help you, it needs to understand you. To understand you, it may need to observe you. And that means the robot revolution will not only be about engineering. It will be about privacy, law, security, trust, and control. Those concerns become even more serious when the same technology is considered for defense and security applications. American companies are already developing humanoid robots for industrial and military-related uses, including logistics and reconnaissance support. That does not mean armies of autonomous robot soldiers are about to appear tomorrow, but it does show how quickly the conversation is expanding. A machine designed to carry materials through a dangerous factory could potentially carry supplies in a dangerous military environment. A robot capable of exploring hazardous industrial sites could also inspect locations too risky for people. The same underlying capabilities can have many applications, and governments are paying attention. The United States has recently expanded restrictions affecting certain foreign-made humanoid and quadruped robots, citing national security concerns. The policy demonstrates that robots are already beginning to be treated not merely as consumer gadgets, but as potentially strategic technology. This is where the humanoid race begins to resemble another technology competition: artificial intelligence, semiconductors, electric vehicles, drones. Countries increasingly see advanced technology as part of economic and national power. Humanoid robots combine many of those technologies at once: AI models, computer chips, motors, batteries, sensors, cameras, advanced manufacturing, supply chains, software. Whoever becomes good at producing robots at scale may develop expertise across an entire ecosystem of technologies. That is why the race matters, even if a humanoid robot never enters your living room. The competition itself could reshape manufacturing, investment, artificial intelligence, and global technology policy. But perhaps the most fascinating part of this story is not what the machines can do. It is what they reveal about us. For centuries, humans built tools that extended individual abilities. A hammer extended the power of the hand. A car extended the power of the legs. A calculator extended arithmetic. A computer extended information processing. Artificial intelligence extended certain kinds of reasoning and pattern recognition. A humanoid robot attempts something different. It tries to combine many of those abilities inside a body designed to move through our world. We are essentially attempting to turn human physical behavior into technology. Walking, grasping, balancing, seeing, responding, learning, working. And once you try to reproduce those abilities, you discover just how complicated an ordinary human being actually is. Picking up a cup is complicated. Opening a door is complicated. Walking across a crowded room is complicated. Knowing when another person is uncomfortable is complicated. Human intelligence is not only what happens inside the brain. It is connected to a body that has spent years interacting with the world. And robots are beginning the long process of learning those lessons from scratch. The question is not whether tomorrow morning every factory worker will be replaced by a machine. They won't. The question is, what happens if these machines keep improving, year after year, generation after generation? Imagine the robot that seems clumsy today. Now give engineers another 5 years, better batteries, better hands, better vision, better AI, cheaper components, more training data, then give them another 5. At some point, the question may quietly change. People may stop asking, can a humanoid robot actually work? And start asking, how many should we buy? That is the transition every robotics company is racing toward. And the clues suggest that race has already begun. Billions of dollars are moving into the industry. Artificial intelligence companies are partnering with robotics companies. Factories are testing humanoid workers. Governments are considering security implications. And manufacturers are preparing for larger-scale production. For decades, Humanoid robots belonged to the future, always 20 years away, always appearing in movies, always coming soon. But perhaps that is the part of this story we should pay attention to. The future rarely arrives with an announcement. It appears in small experiments. A robot moves a box. Another works beside a human. Another enters a warehouse. A company opens a factory. An investor writes a check. A government creates a new rule. And eventually, all those small moments become something much larger. One day, people may look back at this period and realize this was the moment machines stopped being tools we operated and started becoming workers operating beside us. The humanoid robot revolution may succeed. It may move slower than expected. Some companies may disappear. Some promises may prove exaggerated. But the experiment itself is already underway. And somewhere right now, inside a factory, a machine shaped like a human is learning how to perform a job designed for one. The question is no longer whether we can build machines that look like us. The real question is what happens when they become useful enough to work beside us, and eventually, perhaps even live beside us, because the robots are no longer simply being built, they are being trained, and the race to put them to work has already begun.